right, let's talk a little bit about inscribed angle. So an inscribed angle is an angle whose vertex is on the circle and whose sides are chords of that circle. So if we have a circle, okay, an inscribed angle, its vertex has to be on the circle. Okay, so this is the vertex of our angle, and its sides are chords. So remember, chord goes from one place on the circle to another, one place on the circle to another. This is an inscribed angle, and I'll call it angle A right here. Okay, so that opening right there is an inscribed angle. The intercepted arc is an arc whose endpoints are the points of intersection of the angle with the circle. Basically, here's your vertex of your angle. Follow the sides out, and the intercepted arc is the section of the circle that those sides cut out of the circle. So let me change colors for a second. Okay, so this would be our intercepted arc. It's the section of the circle that you're cutting out with your angle. Okay, so again, the angle and the arc. Okay, so here's an example down here. Angle DEF is an inscribed angle. So again, the angle from D to E out to F. That's the inscribed angle. Here's its vertex. Okay, DF is the intersected arc. So it's the arc cut by our angle, its endpoints, D to F, that's our arc. Okay, and DF subtends DEF is another terminology that they will use. We're going to talk about some properties that come about when you have inscribed angles and intercepted arcs. So here are the properties that they give you. The measure of an inscribed angle is half the measure of its intercepted arc. So there are different cases that you can have here. So notice here we have angle B. Here's its arc. Okay, the angle B, is equal to half the size of this arc. So it doesn't matter whether it's the top part of a circle. It doesn't matter whether angle B contains the center. Okay, still, whatever arc, the angle is half the arc. Okay, again here, angle B. Here it is. The angle is half the arc. So anytime you have an inscribed angle, its measure is equal to half the measure of the arc. So what you'll want to memorize is for inscribed angles, the angle is equal to 1/2 of your arc. Okay, so let's try some. Here we have a picture over here on the right-hand side of our screen. We have angle here and an angle here. It asks us first, find the measure of arc VP. Okay, so that's what we're going to find first. Well, let's take a look at where is VP. It's the arc from here to here, arc VP. Do we have an angle associated with it? Well, here's its endpoints. Trace those back, find out what angle you're dealing with. So this 80-degree angle, this is the arc that goes with it. So again, what I always memorize is that for inscribed angles, the angle is equal to half the measure of the arc. Okay, so what is my angle? Well, my angle measure, it said, was 80. That's supposed to equal 1/2 of my arc VP. So what's VP going to have to be? Well, we have half of VP is 80. If we multiply by 2 to get rid of that 1/2, we get VP would be 160. Okay, so even if you want to make your notes even more detailed, you can say not only is the angle half of the arc, but the arc, if you're trying to find the arc, is 2 times the angle. And that's just from solving equations is how that comes out. So let's try the next one. The next one is asking for the measure of arc PT. So it's an arc, so we know we're going along the edge of the circle, our curve from P to T. We want to know what its measure is. We're not sure, but we notice that it comes from the angle here, angle PST, which is 65 degrees. And if we set up again that we know that the angle, when you have an inscribed angle, it's equal to half of your arc, and we put in the information we have, we know our angle is 65, we know the that should be 1/2 of our arc PT. And again, to get PT by itself, we would multiply by 2, and that gives me that PT is 2 times 65, which is 130. Okay. Next, we're asked to find the measure of arc VPT. So let me change ink color so that we're working and can tell the difference here. Okay, well, let's change back to red. So let's see, where is arc VTP? Remember, arc means you're going along the edge of the circle. So we start at V, go towards P, on our way to T. So we go through P, continue around to T. This is our arc that they want to know the measure of. Well, how are we going to find that? Well, notice we found the measure of arc VP, the part from V to P was 160, and we found the measure of PT, the measure from P to T we found was 130. Notice from V to P to T is those two arcs put together. So VPT would be 160 plus 130. It's a 290-degree arc. And finally, we are asked to find arc VT. So where is VT? Well, it starts at V, goes along the edge of the circle until you get to T. I know not to go the direction of P because it would have said VPT again. So from V to T, what's the measure of that arc? Well, we don't have the intercepted or the inscribed angle that makes it, but here we're going to use the facts about a circle. How many full degrees are in a circle? Because notice if we put the arc we just found, VPT, together with one we're trying to find, VT, we get a full circle. Okay, a full circle has 360 degrees. So VT will be whatever's left after we subtract the 290 degrees from the arc VPT. So we just take 360 minus 290, and we find that it is a 70-degree arc. Okay, so there are several ways to solve. If you have an arc and you have the angle that goes with it, remember that the angle is equal to half of the arc. If you have a couple of arc measures, you are welcome to add them together to get a larger arc. And always remember, a full circle all the way around is 360 degrees. So if we need to use that to help solve, we can also. All right, let's try this question, okay, with what we've learned here. Use the figure below to find each of the following. So first, we're going to find the measure of arc ADC, okay? So we start at A. We're supposed to go through D. So I'm going through D on my way to C. Okay, well, that's a pretty big arc. It covers a lot of the circle there. So we want to know, okay, do we have the arcs to make it up? Well, we have a 70-degree arc, but it just covers this section. So that's not going to help us out much because we're missing this part and we're missing all of that. So then we go, okay, do we have an inscribed angle? Do the endpoints make an angle somewhere on the circle? And they do. Notice we make angle B here, which happens to be 141 degrees. So we're going to use the angle and the arc relationship. And so we write down our property. The angle is equal to 1/2 of the arc when you have an inscribed angle. Our angle was 141 degrees. That should equal half of our arc, ADC. So to solve this for the measure of the arc, we multiply by 2 to get rid of the 1/2. To do the same on the other side. So our arc is going to be 141 times 2, or 282 degrees. Okay, so arc ADC, that whole big arc along that outside, was 282. Next, we're asked to find the measure of arc AC from A to C. So we're starting at A, going the shortest route possible to C. I know I'm going the short route because there were only 2 letters in the name of the arc. That tells you to go the short way. Well, what are we going to use for that? Well, we just found the rest of the circle going from A to C the other direction. So we have whatever's left over here. Remember, a full circle is 360. So to find the leftover part, we take our 282 that we found for the other part of the circle and subtract from 360, and that will tell us what is left. And we get 78 degrees. Okay, so the arc from A to C is 78 degrees. And finally, we're asked to find the measure of angle DAE. Okay, so here's the angle from D down to A, out to E. Notice I'm not going along the edge of the circle this time because we're talking about an angle and not an arc. Okay, so this is the angle we're trying to find the measure of right here. So notice we do have the arc for that. The arc that it intercepts is 70 degrees. So again, we're going to use our little fact we have here that the angle is equal to half of the arc when you have an inscribed angle. Our angle is angle DAE. It should equal 1/2 of the arc, which the arc happens to be 70 degrees. So notice this one's going to be solved a little differently. DAE is by itself. All I have to do is this part here, half of 70, which you can do by finding 70 divided by 2. So that tells me that angle DAE is 35 degrees. Okay, so again, we have this one property that we're going off of, but there are 3 different methods we used to find the missing parts in that problem.